And this is what we tried to do is that in 2007 we tried to look at some of the mitigation strategies that winemakers could use in terms of their processing techniques, and this is one of the trials that was done by a winery, and we were very much involved with this as well. And so what we looked at this stage was like comparing machine and hand harvesting, and obviously on the horizontal axis we looked at the pressing fraction. So really obviously the higher the numbers is obviously the more the pressing fractions right at the end. And obviously what we see and what we've compared here is the hand harvest, which is in the maroon, and also the machine harvest, which is in the light blue. And what we'll see is that with the machine harvest there is a gradual increase in terms of guaiacol concentration. And so obviously as the fruit is being as the juice is being expressed from the fruit, there's a lot more guaiacol which actually comes out into the juice. By contrast, if you look at what happens with hand harvesting, and obviously your hand harvesting is a lot more gentle, and also in terms of bunch pressing as well, there is an opportunity here, certainly for the first 400 or maybe 450 litres, depending on how thorough and how observant the winery is. They can actually perhaps mitigate or minimise certainly the early taint levels. And obviously what happens towards the end is that you get a sharp increase, which is obviously almost corresponds to the same level as machine harvested. So obviously the more juice has been expressed towards the end, obviously the more guaiacol is actually going to come out in solution. One of the other parameters we looked at was also processing temperature, and obviously processing temperature also does have an effect. So the colder the fruit, it's probably if it's possible to actually press when the fruit is actually as cold as possible. One of the other issues we looked at was also carbon, because carbon is one of perhaps one of the very selective agents that can actually remove guaiacol. But unfortunately, carbon is it's not really a surgical strike in terms of precision. It's actually a flat earth approach, and it tends to take out quite a lot of other interesting compounds as well. And what was quite interesting was that we looked at 19 different commercially available carbons, and we applied a flat rate of 3 grams per litre to a very heavily smoke affected juice. And so obviously the lower the figures, the more guaiacol that's been removed. So you can see some of the carbons actually very quite ineffective actually removing guaiacol. Some of the other ones, for example, are actually quite effective. So we also fielded a lot of calls from winemakers about what kind of carbons they should be using. So this is the kind of data that winemakers can rely on in terms of what they should be doing if they want to remove guaiacol from their juice. And obviously what's quite interesting here is that the cost of different types of carbons actually varies quite a lot. So some can be quite cheap and other ones can be quite expensive. So, and people are obviously making the assumption that if it's more expensive, therefore it must be better. But some of the better quality ones are actually one of the cheapest available in the market. So again, for winemakers, it's really important to actually do some trialling first, or at least get some advice from a third party. So really, the conclusions are no machine harvesting, chilling your fruit if possible, doing some kind of pressings cut, actually having a winemaker there and actually looking at what they can be doing as the fruit is being as the juice is being pressed from the coming out of the press, and also perform carbon trials at the juice stage. It's not advisable to try and process your juice, process your wine, because obviously you're really going to lose all your fermentation esters as well. So, and a lot of the things that we say to winemakers is that try and do your processing or try and do your treatments, your finding treatments as early as possible in the production stage. And then it's also, once you also add carbon, is also try and treat it and settle it, remove it with bentonite, and then try and get all the bentonite off try and get all the carbon and bentonite off before you actually do any fermentation. And the most important thing is also try and add some solids back to your fermentation, otherwise you end up with a lot of stuck fermentation issues. This is quite an interesting trial that from a vineyard, a very small vineyard. There was a fire event in December 2006, and what we tried to do here was actually try to identify some of the trends and some of the implications of actually what was happening after a fire event. And so what we looked at, there was a vineyard which had about 1,800 vines. And they had a fire event which lasted for about 24 hours and encircled the entire vineyard. And so at that stage there was a lot of comments about what was actually happening, and we're trying to draw some sort of some trends. And so what we looked at, we sampled 4 vines, and obviously this wasn't meant to be statistically significant, so I'm not going to. So you know, it's really just to get some indication. So what we looked at, firstly, we looked at you know, fruit weight per vine. Obviously there's quite a big variation from 1 kilogram to about 4 kilograms, so there's a big variation. In terms of ripeness, again, it's probably, you know, a big variation there. There's no sort of interesting trends there at all. And when we actually harvested the fruit, we actually found that there was some very small amounts of guaiacol. Some was non-detected and some was about 2. And so a lot of the comments at that stage, winemakers were saying, well, you know, we've done some sampling, we've sent some grapes off to be analysed, and we've come back with undetected, and after fermentation it actually ends up being smoke tainted. So what's interesting is that there's a huge variation in terms of on a per vine basis, and that can range from about 4 to 6 fold. So there's a big difference between, and obviously that comes down to topography, where the vine is situated in the vineyard, the lie of the land, etc. And obviously a lot of the fire events obviously happen when the fruit is actually quite, the vine is actually stressed, and so therefore that would probably exacerbate a lot of the differences as well. And what we did at the same time, we also took samples of the leaves, but at that stage we didn't have a technique to actually analyse for the leaves, so we froze the leaves. We frozen the leaves, and we kept them down until such time as we developed an analytical technique. And what we found was that, again, there was a huge variation in terms of how much guaiacol was actually in the leaves. But what was very interesting was that you know, these levels are very, very high relative to what was in the fruit. So obviously what comes from the grapes, you can probably say that, you know, maybe it actually comes from the leaves. And this has also been supported by some of the other work we've also done after this trial as well. So in terms of our red wine making, we also looked at you know, we also looked at some of the trends as well, what actually happens in winemaking, and this was from the same fruit as this this vineyard. So we harvested all this fruit, we put it all together, and we fermented it in a lab scale. And what we found is that the fruit was about probably about 14.8 Beaumet. At the start of fermentation, it probably had an average of about 1 microgram of guaiacol. And as we see, and as the fermentation drops, so 15 Beaumet, about 12 there, about just over 10 there, what we're seeing is that we're actually seeing a very, very sharp increase in terms of guaiacol. Oops. So we see that really by day 3 or day 4 of the fermentation, all of the guaiacol has actually been perhaps liberated or extracted out of the fermentation and actually in solution. And what we find is that even once the wine is pressed, is that sometimes the press wine actually has less guaiacol than the free run. So guaiacol on its own is actually quite soluble. It's very water soluble and also very, very stable. So it's not something that's really going to break down over a long period of time.